Hey, we're going to keep this video pretty short, but it is an important one. We're going to see how logs and exponentials interact and how they cancel each other, which is really important when solving equations with either one. And the notation looks a little strange, so you really have to practice it and be intentional with how you write this. So let's get going. First thing is, what is a log expression? Well, that's pretty simple. It could be a log of any base, maybe base 2, of, let's say, a variable x. So no big deal. That's a log. But what is an exponential? Well, an exponential is a number that is a base, like 2 or 5 or 1/3, a base to an exponent power or a variable power. Okay. And these two types of expressions will undo each other. Let me show you what I mean by that. If I input one of these into the other, so like if I replace this unknown x with 2 to the x, so if I have log base 2 of 2 to the x, because the bases match, the base on the log matches the base of the exponential that's input to the log, well, this log base 2 cancels the base 2 on the exponential, giving us just x, just giving us the exponent. Similarly, if I take the exponential and plug a log in here, I get cancellation as well. So if I have 2 to the power of log base 2 of something, again, because the base of the exponential matches the base of the logarithm that's in the exponent, and it's important that the log is in the exponent of the base, then these cancel, also giving us just x. So again, it's kind of strange to write a number to a log of this with the same base will cancel, and a log of a number to a power will cancel if they're in the same base. Let's do just a couple examples, and that'll be it for this short video. Simplify. Let's look at the first example. Let's simplify log base 2 of 64. And I chose this example because we're going to do it a couple different ways. The first way is just using what we know about logs. We're asking ourselves, so one way to do it is say, okay, 2 to what power equals 64? And the answer is the 6th power. So log base 2 of 64 equals 6 because 2 to the 6th power is 64. You can check that for yourself. Or another way to do it, which isn't maybe as intuitive, but I want to emphasize the property we talked about here. We could think about rewriting 64 as 2 to the 6th power because 64 is the same thing as 2 to the 6th power. And now, because the base on the logarithm matches the base on the exponential inside, we can cancel those and leave behind just 6. Okay, so that is the power of this cancellation process. Number 2, if we have log base 3 of 3 to the x minus 1, well, you guessed it, the log base 3 cancels the exponential's base 3 and leaves behind just x minus 1. If we have 4 to the power of log base 4 of 6, because we have an exponential to a log, we know they cancel and they have the same base, we just get 6. See how fun this is? And last, if we have 5 to the power of log base 5 of 3x minus 2, again, because the bases match, we get cancellation, leaving behind just 3x minus 2. And that's all there is to it. It's really a notational thing, and getting used to understanding that exponentials and logs cancel and building the intuition for that, like You already know addition and subtraction, cancel. Or multiplication and division, cancel. Or squaring a square root, cancels. It's the same sort of process with logs and exponentials.